back to my channel. Today we are going to solve 560 Leetcode Subarray Sum Equals to K. So you are given an integer array nums and an integer k. Your job is to find how many contiguous subarrays add up to exactly get the k. A brute force approach, if you go, don't do this in your interviews because you could check all subarrays, sum each, but that's big of n square, that is time limit exceeded, so you can't do that. So we use smart math with prefix sums and hash maps. So let's do it. We use a prefix sum to store the running total. We also use a hash map to track how many times a certain sum has occurred before. Now imagine this as like current sum minus k exists in a hash map. For example, we would be doing like I'd be showing my notes. Yep, this is the thing. We'll be using a hash map to store its count along with the number. So, and what did I say? Current sum minus k exists in that hash map or not. For suppose here we'll be taking an example as this array. This particular array, we want sum to be as 5. Now we are just looking at this. Look at this. Here at the index 0, we have 1. Okay. And we'll be storing sum to be 1. At the initial stage, we'll be storing sum to be 1. But does that sum equal to k? K is 5, right? So, no, it needs more four numbers, that is minus 4. So minus 4 means I said you that you length is 0. Okay, length is 0. We can't do that. It stores its number along with the count. Okay, so index and number. Next, here in the one index we have 2. So 2 plus 1 becomes 3. Here 3 is not equal to 5, so we need more two numbers to get 5. So negative, so put it as 0, length as 0. Still we did not get the desired result, that is k is equals to 5, right? We want sum to be 5. Just hash map stores it along with the index and the number. Next, moving to 3, 3 plus 3 becomes 6. Carefully listen. 3 plus 3 becomes 6. But what do we want? We want k to be 5. But we had 6. No problem. We By reducing 1, we can get the sum to be 5. Got it? So here in the hash map, if you carefully observe, we can reduce 1. Like we can shrink the window slider. Like we are coming since here 1, 3, 6, right? 1, 2, 3. These are the numbers which are there in the array. If we remove this 0 index and only consider 1 index and 2 index, we'll be getting 2 plus 3, that is equals to 5. So by shrinking the left side, that is 0th index from our count array, we'll be getting sum to be 5. So here what's the maximum length? The new length that we have got, the sum which is equals to 5, that is 2, right? So here we will be assigning it to be 2, and finally we are the maximum length will become 2 from here. Okay, then if we move to next number in the array, that is I is equals to 3 and number is minus 2. 6 minus 2 becomes 4, but the desired result is 5. Okay, we want k is equals to 5. Here it is 4. We want minus 1. Do we have minus 1 in that? No, so we can't consider it to be a longest sub array. Okay, next, move to 5. 5 plus 4 becomes 9. We don't want 4. 4 is extra. So can we even remove 4 from this array? No. So we can't consider it. So finally the maximum length would be 2, as we have got in the starting of this array. So this is the intuition of this, and time complexity would be taking big O of n and space complexity would be big O of n, because here we are using left and right two pointers which are representing a window slider. As I have explained you in my previous video, we'll be using a window slider. We will be going ahead, uh, like if the extra number, that is 1, here in this case we have 1 extra, so we'll be shrinking this left side of window and considering only the required window. Got it? So here the case, left will be assigning to be 0, right is 0 at the starting. Then we'll be considering sum to be the first element of that array. Then maximum length, first it will be 0, And as you know this is the size. We'll be considering n as a size. And while right is less than n, that means less than n means n is the total array length. It would be right pointer would be going till n minus 1. That means the last element, till the last element. As you know, we'll be considering in an array since array starts from 0th index 0, 1, 2, 3 till n minus 1. So here we'll be going less than n, that means n minus 1 till the last element. Okay. This was the main loop, and this is the inner shrinking loop. I said you at the beginning that if left is less than or equal to right, and because right has the condition already, right should be less than n. So if left exceeds right, then that can't be the thing, right? So left is always less than or equal to right, and along with that, sum should be greater than k if these or not satisfying conditions. If sum is greater than k, how can you consider it? For example, we have got sum to be 6, that is exceeding 5. We want k to be 5. Then these two conditions, or like we don't want these conditions. If this condition happens, we'll be shrinking this window. Like left, we'll be shrinking the left. So sum minus array of left element. So we'll be shrinking this left element and adding the left, because to want we want to move right towards right, right? Because by shrinking the left window we'll be moving to right, so we'll be adding it. Then if sum is equals to k, then we'll be checking the maximum length is equals to max of maximum length comma, like right minus left plus 1. We'll be doing here plus 1 because here it starts from 0th index, and so that we need to add it at the end of this code. Also, this is a prefix sum code. As you can see here, we have taken n as a size, and this is the map. This map will store the prefix sums as key and items as the values. Okay, inside elements as the values. And then this pre-sum will running total like prefix sum. Then count will be like final count of subarrays summing up to k. And next, this is like it allows us to count subarrays from the starting of the index, like right from the starting it will be considering. Next, it means we have seen the prefix sum 0 1 time, that is what. Yes. Next, here is a main loop, that is to accumulate the prefix sum from the left to right. This loop runs from left to right. Then next here, remove is equals to pre-sum minus k. That means here's the trick. We want subarray sum to be k. Let's say current sum prefix sum is pre-sum, and we know that somewhere earlier we had seen the prefix, that is sum is equals to prefix sum minus k. That means the subarray between those 2 points sums to k. Okay, from starting till the prefix sum, before the prefix sum. Okay, so we just add all such previous occurrences to our count. That is this, it adds. And next, record the current prefix sum to the map so that future subarrays use it. And it will be adding the current one also if it is equal to the current prefix sum. Then total number of subarrays with sum actually exactly is equals to k will be returning in this way. So this is it is, and time complexity is big O of n, space complexity